Today we're going to look at the FFmpeg graph pipeline for ProRes conversion. We will cover two cases. First one is ProRes with S-Log3 gamma for Broadcast MXF, and second one is still ProRes RAW but with the generic gamma to Broadcast MXF. FFStudio uses FFmpeg as its transcoding engine, so we're limited by FFmpeg ProRes support. Since version 8.0 FFmpeg includes the ProRes RAW decoder, so it's important to use the newest build possible. However, FFmpeg still lacks proper color conversion for proprietary gamma profile like S-Log3. That means we must manually process the decoded stream to achieve accessible broadcast results. Now let's start with simple broadcast template for XDCAM HD 422 at 15 megabits per second. The container must be MXF OP1a. The video codec is MPEG to video. The bitrate is constant at 50 megabits per second. The gap length should be 12 or 15, depends on frame rate. The pixel format is YUV 422p. Resolution is 1920 by 1080. Frame rate 25 for PAL or 30,000 or 1001 for NTSC. Scan type is top field first, and since we are using YUV 422p, the bit depth is 8-bit. Now let's move to audio. For demonstration purposes, we will create 8 mono channels. The first 2 channels will come from the original media. The remaining 6 channels will be silent. We use the pan filter to extract channels. C0 represents the first channel from the input and C1 represents the second channel. Each channel is mapped as separate mono streams. Then we generate 6 additional silent streams with the required sample rate. One important thing, we must use the global flag -shortest. Without it, FFmpeg will continue writing the silent stream indefinitely. For audio codec, we use PCM, and the final container is MXF. Now let's run the graph and validate the result. First, we check the structure of the file, then we verify audio streams. From the original media, we convert audio to WAV and open it in Audacity. From the Broadcast MXF, we export the first 2 mono streams as separate WAV files. When we compare them, we can see that the content matches exactly. Left and right channels are correctly extracted. So technically the task is complete, but we should always play the result to make sure everything looks correct. In this case, we have interesting source. We see the green tint and washed out colors. Let's fix that. I'm not color science expert and this solution is not ideal, but we need to improve the result. First, let's fix the washed out look. This is usually happens because raw footage is recorded in a linear format and standard BT 709 misinterprets it. To correct this, we apply publicly available LUT using the LUT 3D filter. After applying LUT 3D, color becomes more vibrant and contrast improves. However, the green tint is still present. I'm not completely sure why it's happening, but my theory is that it's related to HDR handling and how FFmpeg performed the conversion. The sample layers that support ProRes show the same tint, so the issue is likely come from the source interpretation. To reduce the green tint, we use the lutrgb filter. This filter allows us to adjust the intensity of individual RGB channels. By slightly reducing the green channel, we got much more balanced image. Final result is not perfect, but it's closer to broadcast ready as we can achieve with FFmpeg. I also have another example. In this case, lutrgb was not required. Applying LUT3D alone was enough to improve the contrast and color balance. Before LUT3D, the image looked flat and low contrast. After LUT3D, the colors were richer and more natural. That's pretty much it. You can always copy the raw FFmpeg command from the Q tab or save the graph preset as a text file. If you know better way to achieve more accurate color conversion in FFmpeg, especially for S-Log3 or HDR workflows, feel free to share your approach. This topic is still open for improvement. Stay connected with us on Twitter, support on Patreon, and check out our work on GitHub for updates and community contributions.